So a bit about myself. So I started getting involved in OCaml quite a few years ago in something called MetaOCaml, which was a code generation system, which is type safe by construction, and then ended up developing a static analysis solution using OCaml, and more recently I was involved with the Reason project. So there was yesterday this status of JavaScript survey, and then one of the themes of the survey was that flavors of JavaScript. And then, as you can see, there is a lot going on with types. So what I'm going to present today is a project called genType, which essentially takes the first three, Typescript, Flow, and Reason, and tries to make them talk to one another and understand each other. So one of the things that a type language gives you if you have type inference is that you get to type more by typing less. And now in the same theme, what genType tries to do is that it tries to automate some processes to you. In particular, the process is to integrate JavaScript code, whether it's typed or not, with Reason code. So the solutions that exist with gradual typing, so here I refer specifically to Typescript and Flow, I like to think of them as space-time gradual typing. So space in the sense that you add a little bit of annotation over time. I annotate a type here, a type there, and then I get more and more of my code annotated. But then there's also a time perspective in that, because the systems are not fixed. They evolve over time. So it's very important that for a community that is not used to type, when you introduce them initially, you want to do it in a gentle way and then eventually add features. And that's what the systems are doing. So if you use Typescript today and then you use it again in 6 months, chances are there will be more features and more things you need to change, and then it becomes gradually more strict. So this is one way to go about that. And the other way is what I like to call file-gradual typing, is that the Reason process of converting from JavaScript is designed to achieve. So the idea is that you take one file at a time and then you convert it completely. And it's still a gradual process, because if you want to embrace the new technology, you do it one file at a time. But it kind of draws the line on what you can rely on and what assumptions you make on. So you can think of a single file like a little theorem. Say, if it's true that all what I assume about my interface with the other language is correct, then I have a bunch of guarantees, such as type safety. So the goal with genType is that to have a system in which you start from Reason, which has a type system which is very old and so likely to stay stable, not change very much, and then map to these other systems, and then in a way that you only type things once, but then you can keep up with the evolution of the other systems without having to change your types. Right? That's the goal of the project. So initially, the project was called genFlow, so it actually came out of embarrassment. The embarrassment was, well, we have type JavaScript with Flow, we have Reason, and then we have interop, but then at the barrier, it's completely untyped. So we need to do something about that. So that was the kind of the initial. The initial goal was just, okay, let's try to do more typing between Flow and Reason. And then the project has evolved in scope and the number of things that it does. So first of all, it's not about static types. So it's about types and it's about values as well. And it starts from the observation that you have an idiomatic way of representing your types, which is different for Reason than it is for JavaScript. And so the goal is to keep the JavaScript idiomatic representation and the Reason idiomatic representation, and then make them talk to one another. Second change was that, well, I've shown you the graph before. TypeScript is very popular, it's growing very fast, and so it made kind of total sense to cover both Flow and TypeScript at the same time. The second change from the initial project was that it's not only one direction. So the initial project was, okay, let's export some type Reason into JavaScript. But it works the other way around. It allows you to import type JavaScript into Reason. And the other aspect is that basically this goes back to what I was saying before about kind of not changing over time. So the goal is to keep up with best practices. One thing that Flow is doing at the moment is to go for strict object types, in which if you declare that there are 3 fields, you cannot have the 4th fields. And this is a change that should be completely absorbed by this interface. So genType should adapt to that so that the code you write doesn't change and then can adopt to with the best practices. So technically, I was just trying to describe at high level what's going on. And so at the high level, this is what happens. So there is a Bacoscript compiler. It takes a program P in Reason with type T, and then it produces some JavaScript in the Reason representation, which operates on some data type definition, which is also in Reason representation. But then you can also start from the same type and then have a more idiomatic JavaScript representation, which I call J of T. So now we have these 2 representations, the Reason idiomatic and the JavaScript idiomatic. So we can start defining some conversion functions, which are built into the system, so you can go between Reason and JavaScript and vice versa. And so at the end, you can combine all of this together. So if you want to export a value, so suppose I have a Reason value v of type T, the first thing I do, I run the Bacoscript compiler, which gives me ROV, which is the value in Reason representation, and then I convert it to JavaScript. So that's basically what's going on behind the scenes and why it works. And there is pretty much nothing else at high level. So concretely, if you look at one example, we can start from the record type, x of type int, and then one value, which is x is 2. That's the Reason value. Now, let's see what is the runtime representation. We run it through the compiler, and then it turns out that this record is represented as an array. So it's an array which contains 2 in it. So that's great for efficiency. For runtime execution, it's not great if you want to interface with that from JavaScript. So what is the more JavaScript idiomatic representation? Well, it's just an object. So it's going to be an object with a field called x. And then the conversion functions convert an array with 2 in it with an object and vice versa. And so if I want to compile this value and export it, I first compile it with Bacoscript, I get an array, and then I export it as an object. So this was about exporting Reason values to JavaScript. Let's look at the other direction. So for the other direction, what's going on is this. So I'm inside the Reason word, and I want to access some type, which is defined in JavaScript. So it's going to be a Flow or a Typescript type. So the way to specify that type is I want to have the type called T, which is in some file, f.js. Now, the idiomatic representation in JavaScript is just f.t, whatever that definition is inside the file. Okay? The conversion values are like before, and then if I want to import a value, what I do is I access the value, and then I convert it to Reason. So that's the way I import it. So it's pretty much like a normal FFI integration plus the conversion of the representation. So that's okay, but it's still untyped. So I'm taking some JavaScript in, I don't know what it does, and I hope it has the right type. So the only extra thing I need to do is I need to check the type. So I need to also assert that the type which is defined in JavaScript corresponds to the type I think it has. And so what I need to do is to implement an assertion which says the value is the type that I expect. So the type is whatever the idiomatic JavaScript representation it is. So what that means is that importing a value from JavaScript means convert it plus do a type assertion. And the type assertion is performed either by Flow or by Typescript. So if there is a problem, you're going to get a type error from Flow and Typescript. So that's the way things are set up. So enough theory. It's time to look at a little bit of examples. So
I mean, I can understand this sounds very abstract, what we just discussed, but I think in a practical context it makes a lot of sense. So I try to boil this down as much as possible so everyone can follow along. And for that, I prepared one example, which is, we'll just open it in code. So who of you is using VS Code? Okay, quite a lot of people. That's good. And I also use the GitHub theme, so you're already familiar with the syntax. Cool. So what we built is we just used create React app with the TypeScript flag. So this is a very, very standard out-of-the-box TypeScript project. And I just want to skim through it a little bit so that you get familiar what's happening. First of all, this is way too big. 1 second. I think every time I connect a projector, it's messing up the... Yeah, here we go. So we will just start the project with React scripts so that we can get a feeling on how this looks like. Yes. Yay! A very beautiful page. I learned tachyons the other day and I love it, so I put it to use here. So this is just a very standard little website. We created an app with some sections in there, and we also created an existing TypeScript component which takes a string and yields a logo in whatever language you define. So we have TypeScript, OCaml, and Reason. We have some styles, which is something. And just to show you, I already did some pre-work because I know whenever I do a presentation, it never works when I do npm install. So we have BS Platform, which is the BuckleScript compiler, and we have ReasonReact in there as well. Also, we added the BuckleScript configuration, which is just straightly copied from BuckleScript. And another one thing which is interesting is that we put in-source to true. That means whenever you compile a Reason file, the compiled JavaScript file will sit right next to it in the same folder. And I find this quite useful if you're doing a lot of interop. It makes a lot of sense to use in-source. Right. So what we try to do, first of all, this has nothing to do with genType right now, but let's start off with writing just one component, just to be a poser. So we do a color square component, which I wrote like a million times. So we just use a snippet here. Right, so this is just the standard procedure of writing a React component. And let's define a property like a prop type, which is of type string. It's called color. And then we have a size, which is also a string. For brevity reasons, I do strings all over the place. Please don't do that in real work environments. And what we will do is we will create a new inline style. And we just pass in a background color, which is of value color, what we pass in as a prop. And then we have a height, which is size, and we have a width. And then we close it with a unit, which means execute this function. So now we have a style in there, and we apply this style to this div. And since we are in Reason land, we can do property punning, which is really convenient. Then we reformat this whole thing, and that's it. So we have now a Reason component integrated in this thing. And so far, we just have one BuckleScript file here. So if I would look into it, it's some JavaScript. It's the ReasonReact API mapped. And now we have a problem. So I'm in a TypeScript application. So if I would do import color square from colorsquare.bs, then it's not working because .bs is a JavaScript file, not a TSX file. Also, another problem is that we have a ReasonReact component, which is not the same type as a we have a ReasonReact component, which is not a ReactJS component. They are different types, if you think about it. So let's try this again. We need a tool which solves all our problems, and that's where genType comes in. And I'm really I told you that I don't do npm install on presentations, but we'll try it anyways because I'm convinced it will work. So this is the only thing you need to do. npm install minus d genType, minus d means def dependency. And it will download binaries which work for Windows, Linux, and macOS. We spent a great amount of time optimizing for all platforms. I was sitting there on my Windows gaming machine, like just to fix a bug I found with file paths, for instance. Anyways, so now genType is installed, and we can find it in our package dependencies here. And now we need to hook it up to Buckescript. So we have the compiler. We now need to teach the compiler to use genType whenever a new file is being saved. And this is done. You can look this up on the GitHub project, which can be found here. Christiano sees his GitHub, genType. There are install instructions going through this very complicated procedure. And what we need to do is now we need to, first of all, let's first hook it up with Buckescript. So we have this thing here. Buckescript uses an environment variable to execute arbitrary commands whenever a new file is being created. A new CMT file, is it called? Don't worry about it. So we put it in here in the build command. So whenever we try to make the world, we put it in. Oops. Like this. And that's it. So whenever you run bs build, it will automatically pick up genType. genType is the binary located in your node modules.bin folder, which you installed. So it's located in your project dependencies. That's one nice thing if you have multiple projects with different versions. I was a little bit lazy and I was a little bit worried about the presentation. So I put a globally installed genType in my env variable. Don't do that. But just so you know, it works like this as well. Cool. So now this is our setup. Now we need to teach some configurations about our project because, of course, genType can compile to many different languages. So what we do is we just add here this genType conf, and with prettier we can, I think, prettify it or not. So there are 3 different languages. First of all, is Untitled, which is just plain JavaScript. Then we have Flow, which we don't use today. And we have Typescript. We go with Typescript, of course, right now. And that's it. So now what I like to do whenever you set up genType for the first time, you already have built artifacts. And Buckescript does a lot of caching. So first of all, just to make sure that everything is clean, you just run the clean script for now. All the artifacts are gone now. So you can see it on the left side. We have our color square still there. And now, when I save, I should create new files there. Or maybe sometimes I just to be sure. You know, you never know. Let's make a small change. So. Does it want to generate it, or is the file broken? I had this feeling that the file's...
Okay. You haven't put any annotations.
Oh yeah, sorry. Okay, this was a human mistake. So I was talking about that we cannot import the file, right? So we need to tell genType what to export. And for that we have something which is, I'm so happy that I have the creator sitting next to it. So what we need to do is just annotate it with genType, and now it's working. So it will pick up, it will see the annotation, and now we will generate a wrapped component. And as I said, there is a ReasonReact API to wrap a ReasonReact component to the ReactJS space and vice versa. But this code is very, very tedious to write. It's not complicated, but it's very erroneous. And this is what genType takes away. So now we have this wrapper component thing, and we can happily use it in our app. So we copy this section. And since I don't need to write CSS because I'm using tachyons, I just do some light gray. And we will use, oh yeah, we need to import the color square, of course. And we need to use, this is important, we need to use the generated version, of course. Because this one contains the default export thing. And now we can use it. And now is the interesting part. There is one property, or two properties in color square, size and color. And now I didn't do anything, but Typescript will pick it up and tells me that color is missing in type empty object. So we are missing the color property. So we give it color, and then it will still complain that there is size missing. So all the type information is still there. We just wrote a reason component, and we just seamlessly integrated it into the TypeScript thing without losing any type information, which is great. So we give it a size of 100 pixel, so it compiles. Yeah, no compiler errors. So hopefully it will relaunch it, and now we have a red square. Thank you. But I know what you're thinking. It's like, okay, how many times do I write a color square? Not many times, but I do. Let's make it a little bit more spicy. So we add a color with, maybe let's do blue and yellow so it's more accessible. Oh, yellow, maybe orange, right? So we have a variant, which is a more complex data structure. You know, a variant is not expressible in JavaScript, so you need to map it manually, which is also very tedious. We don't like to do tedious stuff. We want to do productive stuff. So we add color as a property now. So first of all, we need to map the color. So we make a color string, we pattern match on the color. If it's blue, we just use blue as a color. And if it's orange, we use orange, of course. And then we just use the color string in the background color. That's it. So now we compiled it, and now this is the use forever part. You compile it. It will generate a new genType file, but here we will get an error actually. Cannot find name color, and that's right. Because we didn't tell genType what color is. You need to be very explicit about that. So what we need to do here is we just add genType here as well. So genType will pick it up, will export it, and hopefully we will now have the right type. So now it recognizes it. And it will create the constants for the variant tags. So now it maps to the internal representation of the BuckerScript value. Which is not what we need to know. You don't actually have to look into this file. You just generate it and you forget about it. So let's see what's happening here. Now it's complaining because type string is not assignable to type color, of course. So what we need to do now is we need to use these constructed elements. We have blue and we have orange here. So now we can use it just like this. Don't forget the curly braces, because in JavaScript you need to do curly braces whenever, not like in Reason. Whoop. Whoop. So then we have orange. It did compile. So if it compiles, you can be pretty sure that it worked. So, super. Okay, there are still some people like saying, okay, this how many? I mean, a simple variant is very, simple. Can we make it a little bit more complex? Of course we can, because you can be arbitrarily complex with it. So let's say, just remove orange for now. We use RGB, and we give it a payload RGB. And just giving a payload of integer and string is boring, so we give it a record as a payload. So we define a type RGB, which is R. Don't do strings, please don't. RGB. Of course, we need to tell genType about it. And now we need, of course, we have very useful pattern matching. So we get the values out of there, RGB. And you can tell I practiced this because everything fits in place so nicely. So we just put RGB in here, which is stringly typed. Stringly typed is very bad. Okay, but you get the idea. So we have a record which is nested in a variant. And of course, we will be able to pick it up. And what, first of all, we see that orange doesn't exist anymore because it's gone. So we can use RGB now. And RGB is not a constant value, but it's more a function because it receives a payload. So now RGB is a function and we can use that. And we define it here. So we use it here. We define RGB and a record can be represented as a JavaScript object with the gentypings in between. So we have red, which is 0, 0, blue, which is 0, 0. And then we do the proper way with 1, and then, of course, it will tell me that this is not assignable to string, so this is also properly typed. And if this worked, hopefully, we now have a black square. Right. Okay, so these are like, you can play around with it, you can nest it, you can do very crazy stuff with it. And if you find any bugs, of course, please let us know. But we just did one direction right now. So we created some ReasonReact components, which is very common. And you port it to some existing code base, you want to use it. But sometimes it's also the other way around. You have a huge legacy code base and you just want to reuse these components in your Reason app. And this is also possible. And this is a part I didn't use too much, so please bear with me. But I will do it live. Yes? You tweet about it already? So what we will want to do, so first of all, go back. So we have existing components here, which is just an icon of each language. And we called this component langbox. So what we'll do is it's a very useless component, but you get the point again. It gets a prop of type, like a property lang with a string. So now we create a new component which is called langbox.re. So it represents the reason mapping for this. And because I have a very bad memory, I need to go to the GitHub page. And down there you can find very good documentation about everything. And here you can find the mapping, how you can import an existing JavaScript component. So first of all, we replace this one, which is langbox. And then we need to refer to our langbox.re component here, just to give it a little bit more information, a little bit more context, what it needs to generate. And this looks scary. This is an annotation. So we have an external make of type something with an A. So the generic A is children. This will be inferred. And this, don't worry about this. It's just a ReasonReact API thing, which you usually don't use. So what we need to do is we just need to look at the component and we see, okay, we have language with type string. So we just put in language with string and we save it. And now we have a ReasonReact component which we can use in our Reason app. So we go to color square because I'm lazy. We put it in there. So now we can go ahead and just say langbox.re OCaml. And if it worked, we should now see the OCaml in there. And yeah, this is a little bit more complex. If you go from JavaScript to Reason, you probably have to play around with it and get a feeling for it. And there's still, of course, a human factor involved because you need to look at the props, okay, and then map it manually. So it's usually easier to do it the other way around. If you have a strongly typed language like Reason and OCaml and port it to Typescript or Flow, it's usually more straightforward. Yes, so this is the demo, I think.
So just to quickly wrap up, what is the current status of the project? It's been released at the beginning of summer. So there were quite a few releases. With 1.x was very recent, a couple of weeks ago. The feature set has been kind of growing quickly, but now it's pretty stable. And it's used in production, so it's reasonably tested. And always look at the generated code and check it for yourself, just in case. So in terms of features, so I was mentioning before, so it's about types and it's about values. It's about importing and exporting types and values, and also about ReasonReact components and wrapping them automatically both ways. And it has 3 backends, Typescript, Flow, and also an untitled backend. If you use the untitled backend, you still get all the conversion between the Reason idiomatic data structure and the JavaScript idiomatic data structure, but without the type checking. And there are a bunch of types which are supported, so they cover most of what you probably need, but from time to time there are new feature requests and then they can be added. So in terms of feature, right now in terms of documentation there is a big README which is comprehensive, and more can be done, like tutorials, stuff like that. And one thing that I'm quite interested in is now that you can get the languages to talk to one another, how do you publish libraries which are typed and can be consumed in a typed way from Flow and from Typescript? So that's an interesting kind of direction that we plan to work on. So one possibility is to support definitely typed and Flow typed. Those are kind of 2 communities where people contribute their typing annotations, and so there is a lot of work there. So it would be good to use that. And these types tend to be best effort, but if we had an automatic mechanism to import them, that would be a great way to bootstrap a process in which we have types that then we check and we can trust and then we can maintain over time. So that's it. Thank you very much.